Hey guys, what's up? Audioholics here with KissAnalog.com. Today we have it's a pretty controversial subject, I guess. You know, I was actually kind of surprised that there's this much controversy around it. There's always extreme sides to arguments. Mostly always. Hard to say always. But in this case, wow. I was doing some research, and I was actually doing research for another video I have that's going to come out very soon. I've been kind of talking about this video for a little bit, but in doing that, this one is a related video, a related topic, and from the thumbnail you can tell it's cables, right? And the audiophiles, wow, jeez. You know, back when I was a kid, back many years ago, I remember they cleaned up audio specs. Car audio, for instance, they used to talk about peak-to-peak audio power and all this craziness. And a lot of that has been kind of corrected, even though there's still a lot of that out there. But, wow, I just thought that this whole subject wouldn't be quite as crazy as it is. So, on one side, you have the camp, who, and really it is a camp, man. They're really camped out. They really say you have to listen, you have to experience. I mean, those are the words they use. And, to believe it. You have to be a believer, Like one guy talks about, I want to drag you up and make you a believer. I want to drag you up with me from your lowly place down there amongst the disbelievers, where you don't understand. Let me drag you up to become as good as I am in audiophile world. And those that you don't want to be dragged up, maybe you should leave the audiophile world. Go find another hobby. Wow, that is just crazy talk. To me, it sounds like talk from somebody who's very insecure. They're insecure because on the other side of the argument, you have the engineering community, the science-based community, and they want to do measurements. I want to do measurements. I want to prove why this is better than that, or why this spec or this standard is what we should be testing to, and why it makes more sense than this one. And but in this case, wow, these guys have become so polarized, and they just can't get together. In fact, the believers camp, they don't even want to do double-blind tests. Like, they don't want to be held to that standard because it's just so obvious. If you can hear it, you'll be a believer. Just come to our camp. Let me drag you up and be in our camp. You'll believe it. And then you'll feel good about spending, oh, I don't know, minimum $200, $250 for a cable to multiple thousands of dollars or tens of thousands of dollars. Believe me, I mean, it's crazy. It is completely crazy. So, wow, I mean, if I could spend that much money on speakers, I would be so much better off. And if it makes such a huge difference, it's measurable. All right, so here's the thing. On this rant video, where I give my opinions, where everybody has one, right? So where I give my opinion, it's based on, the experience I've had, my thoughts, my analysis, things like that, or just how I feel about something. But in this case, yeah, let's talk a little bit. We're going to try to keep things logical, and I need a strong beverage for this talk. All right, so let's start with the camp of the believers. The believers who have the experience and, they've heard the difference. If only you could hear the difference. And if only you would buy my cable for a 30-day money-back guarantee. And by the way, you got to burn them in. Burn them in for 8 days, 24 hours. And I understand there's CDs out there that you can play, but who's going to listen to music for 24 hours. And if part of the burn-in is just the thing powered, just sitting idle, does that count for the same as when you're playing, you know, 100 watts, 200 watts, 10 watts? Is that the same? Does that burn-in time count for the same? And where's the science in this burn-in? Again, things have to be measured. So I guess I'm going to be considered a naysayer because I'm not a believer. I'm going to be considered a disbeliever, or one of the crazies, or a flat earther, which is quite ridiculous. It is. All right, so you know, let's talk about the people from the believers camp. You know, the experience. You have to hear it to believe it. I'm going to pull you up into my camp, so you know, I'm going to enlighten you. You know, let's talk about those people, or this character. Very insecure, I think. The way so defensive and calling names to the people, and just because people want to take measurements or people want double-blind tests, those are naysayers or disbelievers, or they should get out of the community and find another hobby, and they're not doing any good for the community. Well, I mean, if doing good is to get on the snake oil wagon and to pitch, you know, insane ideas, then yeah, I mean, I don't want to be part of that crowd. I want to be on the part of the crowd that says, hey, here's the science, you know, here's what you should choose, you know, if you want to. Here's a difference of this from that. So an ironic part about this particular person I was watching do all these videos, and just to me seems so insecure and so defensive. When this guy's building speakers and crossovers, he sounds so much more at home, and you know, he's got the science in this realm of his experience. He's got the science because he actually shows measurements, and he can show this speaker versus that speaker, this crossover versus that crossover, and can show those things. But yet when it comes to cables, there's no science. Science doesn't matter. You got to hear it and believe it. I mean, how can you talk out of both sides of your face that way? I mean, I just don't get it. Like, and no, I'm not going to become part of the believers. I'm not, you know, if I were to hear something, I would find out how to measure it, because everything should be measurable. And if we're not measuring it, it's because we haven't learned how to do that. So instead of taking all this time and energy calling the science-based people names, naysayers, crazies, you know, flat earthers, which that's just ironic to me, that someone who, let me pull you up into the belief camp, is the same person that's calling the science-based people flat earthers. I mean, isn't that the opposite? I mean, we can prove the earth is round, right? That's science. That's easily proved in science. It's hard to prove things that are belief-based, experience-based. And once you know, a non-scientific person or a non-engineering person you know, learns something through experience, then those scientific community, that engineering community, should be able to measure that and explain why it is they experienced what they experienced. But after all these years, it's just craziness. It really is. Let's get away from the science right now, which this is science. I mean, the people that study this, you know, human science have shown this to be true. When we talk about placebos, right? That's been proven over and over in all different types of fields. The placebo effect is completely true. And as a matter of fact, I think even both camps will admit to that. but I think we all know that logically to be true. So, okay, so if you see something really cool that you're going to put into your system, you're going to love it, even before you hit the power switch. And you can't help but think it's going to sound better. You just can't help that. If you believe it, you know, you'll achieve it. But, you know, so, you know, when you dress well, you feel well, right? You feel good. And so if you think something looks great, it's going to sound great. It's going to sound better. It's just the way we're put together. So if you have this belief that this cable makes this difference, and you have the money to spend on that, then heck, go do it. But know that it's in your mind. That you have to know that it's a placebo. And maybe what it is maybe there's a trigger in your brain that actually allows you to hear better. Maybe it just opens you up. It takes away the stress that maybe you haven't done everything to your system that you possibly could have. You know, so that's worthwhile, right? And there's some science to that. But the science that says what comes from your speaker is different, that is unproven. And with all the money going into cables, with cables costing more than your amplifiers in many cases, there should be some science there. Now, it's true that a lot of these companies don't have real engineers working for them. At least that's what I understand. I know that they don't have big teams of engineers. I know that I've worked in the power industry for pretty much my whole career. I was still in college when I got my first power supply design, doing power supplies for jet aircraft. Needed a drink. All right, so, you know, I got my first engineering job. I paused there for a moment. Okay, I got my first real engineering job. Still in college. I was at UCLA, and I got a job with Lear Electronics. They were doing the computers for the for the jet aircraft. Okay, and some of the stuff was planes that were, you know, secret or top secret. We didn't even know the names of the planes, but it was for the flight controls. So very sophisticated power supplies, you know, just very sophisticated electronics that drive those jet aircraft, because the controls of those aircraft have to be perfect or the guy's going to be biting the dirt. So anyway, since then I've worked in on products for space. I've designed my own for space, as well as I worked on the International Space Station. And I can tell you that with all the money that these big engineering companies, you know, have that I've worked for, and the military, you know, specifications, and even in the consumer industry that I worked in, the DirecTV, I designed the power supply for the first high definition box that went out years ago. So, you know, I've done, and I did that as a contractor. They hired me, and I got paid pretty well for doing that. So I've been in both sides of the fence, and even in the, I guess in the commercial world, I've worked for a couple of small companies, but mostly big companies. And with the big engineering teams, you do see a difference in the engineering. You do. In the smaller companies, you don't see the level of engineering. It's just the way it is. And these audio companies are smaller companies. And although they do really nice work, I'm not saying that, they've done amplifiers over years and years, but these same companies that are doing amplifiers, they do cables, and they have no science behind it. I mean, that should tell you something, because there's nothing to show. I mean, if that doesn't make sense, then, you know, I mean, okay, so there's different cables, right? We have our interconnects, and we have our speaker cables. And both of those cables have their own virtues, and probably the interconnects are the ones that I would, you know, put more thought into if I'm buying them. I certainly wouldn't spend a lot of money, but you know, there's lots of options that are low cost that are very good, and I'm talking under $200. If you're spending $200 or more, it's because of out of fear. You're afraid that you're not going to hear what the belief camp's telling you you're going to hear. So that's really what it is. I've done a lot of research on videos and on the internet looking for proof of cables, and there is one guy who I met back in college, Ray Kimber. Super nice guy, just very hospitable. I went to his factory, and I didn't expect to meet him. I was kind of hoping I would. It was kind of early on in his career, and as far as being Kimber Cable. And I went over there because I was building speakers, and I got into audiophile stuff back in college, and I couldn't afford the kind of equipment they had. So a friend at school knew a guy that had a listening room. He took me over there. We first went and bought records, and I think we bought Pink Floyd, Dark Side of the Moon, and I bought a Grateful Dead album, and we went over there, and first of all, I saw his room. He walked us in the room, left us there, and it was just a small couch, kind of like a love seat, kind of couch, one of those little small couches set up in, I guess, the perfect sweet spot of the room. And he had his electrostatic speakers with some subwoofers, and off to the right was a rack of equipment that was just stuff I had never seen before. I believe the turntable, the platter floated on air, so there's no bearings or something. I don't know. It was craziness. I mean, I saw this stuff. I'm like, wow, this guy's got a lot of money. And I mean, that's first of all, yeah, this stuff has to sound good, but it did. It was amazing. People talk about sound stage and all that. Yeah, there was things I heard going over my head. I mean, it was incredible. But I don't think it had anything to do with his cables. So anyway, I want to pick on power cables, okay? So I'm going to pick on power cables in this video. Power cables are the easiest target because it's the most insane. And you can make some type of argument on the other two types of cables, the other kinds of cables, but the ones that actually carry signal, the thing you're listening to, but the power cable is not what you're listening to. And so when I heard about power cables getting sucked into this cable controversy, man, I that part just blew me away. And it's so easy to measure that stuff, guys. It's just easy, and it has been. And there's people, and I'll put the links below. But if you guys know this controversy, the guy from Audioholics, he's been kind of arguing this thing for a long time, and the guy looks to me like a real engineer, and he's been in similar kind of places I have, and so I understand his background, and I understand his science, which when it's science, it's just data. It's like, I don't know how you disprove data. But anyway, so, and then there's the Audio Science Review. That guy does incredible work too. He's a little bit newer to the field as far as the YouTube channel, I think, but he also shows the science and the measurements and the data, and yeah, and the other camp, there's nothing to read, or all you can do is listen to the guy on his podium, preaching the gospel. That's what it sounds like, right? Holy smokes. Okay, let's talk about that. Alright guys, so one analogy that I've heard used in the argument between the two camps is the thing like in the power cable, where power lines come for, miles, they say, but whatever the distance is, hundreds of feet from the transformer that's outside your home somewhere, and maybe you're a couple doors down from it, whatever. So you have these wires of power come to your house, and then once they hit your house, they come in and they go through your service panel, your breaker system, and then they're distributed throughout your house, right? So then you can have wire, solid wire, Nomex, sometimes it's referred to here in the States at least, and you're going to have this wire traveling through the walls and to your socket where you're going to plug in your, tens of $1,000 cable, but for 4 feet. And a lot of times people say and then the last 4 feet matter after all that, and people say, well, of course it does. And like one, character talks about, yes, it does, but he can't tell you, even though he sells these cables, he can't tell you the right one for your room, because he says there's some balancing act between the filter of the cable and your system, and you have to find the right one, this balancing act. It's utterly ludicrous, okay? So I've dealt with power systems on jet aircraft, on jumbo jets, where they have lots of feet of wire, and every seat in the plane has, an entertainment system. And I can tell you that wiring isn't special. At the very most, the interconnects might be coax, but they don't run a lot of heavy, expensive cable, okay? In a jet aircraft, you don't have shielding on your power cables, okay? Your power cables in space don't have shielding on them. You don't have the cables that bring the power to your unit. They do that, and once they come to your unit, that power is processed. So how they get to your unit, the only thing that matters is the DC resistance. Okay? Doesn't matter how much inductance or capacitance there is there. It just doesn't. These products I've worked on, many of them for commercial, I have to be UL certified and EMI certified through FAA. For the military, the standards are a lot tougher, a lot stricter for EMI. If those fancy power cables did something to help, we would use them, because that would be way cheaper than the hours and hours sometimes spent trying to get a product to pass EMI. Okay? And those power cables just are not going to do the trick. Okay? So there's an EMI filter. The first thing that your power hits is an EMI filter inside whatever unit it's going to. If it has a power supply, it's going to have an EMI filter. Okay? That EMI, the job of that EMI filter is to keep one of the jobs is to keep your product safe from the noise that's on the power system. But more so, it's to keep the junk that you're generating from getting into the power system. If everybody's responsible for their own junk from getting into the power system, then all the other products that are connected to that are okay. That's the idea. Okay? So when you have these multi-billion-dollar aircraft flying around that don't have these fancy audio cables in there, there's a reason, because it's snake oil. The power cables don't need that. They need low impedance. Okay? That's what they need, is ohms. So large cable, yes, sure. To a certain extent, it's not going to help you anymore, but you need a cable big enough that can carry the current without heating up, is generally what it is. If you fill your cable after running at max power, and if it's warm, if it's just warm, it's probably okay, but if it's, feels a little too warm, it should just be maybe warmer than room temp, not much more. And if it's just room temp, then it's awesome, But going bigger than that is not doing you any good. Braiding it is not doing you any good. Putting a shield around it or double shielding it is not going to do you any good. Okay? It's not going to make your sound out of your speakers any better. Alright, so one of the videos that I watched, which I watched many, but one of the videos I watched from this fellow, who seems to be, of all the people I've watched, this guy seems to be the most insecure about what he's trying to sell you. and he's just so befuddled. He's just so upset with the disbelievers and the crazies and the naysayers and the flat earthers, which it's like, dude, you're the flat earther. You're operating on a belief-based system. That's a flat earther. We're the science people. We're the engineering community. You look stupid calling us the flat earthers. It shows your insecurity. It's just crazy. Well, he did this test where he took several cables. He took a regular old power cable, probably a lot like this one. Nice cable. He took one of these and he connected it to a receiver, to the antenna of the receiver. And you could see that, you know, from the station it was picking up, that it was picking up a good sized signal. Well, imagine that. Putting some copper on an antenna input. Wow, that's crazy that would do that. And then he later on in the story he talked about how his dad would have him touch it and, you know, do this kind of thing and act as an antenna himself. So that's because those antenna inputs are very sensitive. Well, but then he put a braided cable on it and it didn't show as much signal, which would make scientific sense, which is a measurable thing. You can measure that cable and you can make that assumption before you ever connect it. And then he took his super expensive cable, showed no signal. Well, again, no surprise. As a power cable, that test meant absolutely zero. Oh, well, actually, I'm sorry. It actually meant everything. He actually proved the science community correct. He just didn't understand the science to know that he disproved himself. But in actuality, he disproved himself. He finally did a test that did two things: showed that he didn't understand the science, and two, that the science of the power cord is there. That receiver was plugged into the wall with the power cord, correct? So if that power cord was picking up RF like the ones he put on the antenna, and that antenna is so sensitive that it was able to pick up that signal, but yet that signal, that needle stays flat when nothing's connected to it. Why? Well, there's a power cable already connected to the wall, and that wall has many feet of wire even going outside the building. That's an awesome antenna. I mean, isn't that the argument that you're getting RFI, radio frequency interference, EMI, electromagnetic interference? That's all kind of the same thing, right? And so you got this huge antenna when you plug that into the wall, but yet that energy, and so, okay, so what that would mean is that you've got a lot more energy on that antenna than you do with a small antenna. So even with that power cord connected to that huge antenna system, you can't hear anything. That needle on the front of the receiver does nothing. So that tells you that whatever radio frequencies that power cable is picking up that's actually plugged into the power supply is not coming through the system. It's not sneaking its way through the electronics and getting onto the RF input and coming out as a signal on the front end of that unit, right? But yet, even if you don't put copper, you just put your finger on that antenna, you'll see that needle pop up because it's very sensitive. And we're actually poor antennas, our human bodies, but those things are so sensitive that they actually pick up our signal. But yet, plugged into the receptacle that's connected to all the other wires, which is an awesome antenna grid array, somehow that doesn't pick up enough energy to even budge that needle. Because, as all of us know, all of us engineers and science-based people know, that that signal cannot make it through the power supply into your electronics. Can you imagine the aircraft flying around, the jet aircraft that have all the high-powered electronics that are very high-powered radios in there that can jam, that can do all these things, but yet they don't interfere with each other, and they don't have a bunch of shielded cable to their power. Their power inlet does not have that. Okay, so it's crazy. Let me show you something, okay? All right, I needed a drink. I said I needed a strong drink, right, for this talk. I just think it's crazy. It's utterly ridiculous. But this is your input power, okay? It connects up here. I didn't show the terminal that connects to the chassis ground. So there's one here that goes to chassis. That's your earth ground connection. That makes the service entrance where your power comes into your building. It's the only place that that connection's made. So your typical EMI filter, you're going to have Y capacitors. The Y capacitors are Ys because they go from either line or neutral, either line to chassis. So those are your Y capacitors. And you have your X capacitors. They're X because they cross between your power lines. Then you have a common mode choke. You have another X capacitor, common mode choke, some Y caps, another X capacitor, and differential mode chokes. Okay, these are differential. So common mode works on noise that our power cord is supposedly picking up, you know, because it's going to pick it up on both conductors equally, right? That's common mode. So it's going to get filtered here. It's going to go to chassis. Okay, it's going to come down here. It's going to get filtered out again. You could have some white caps here. You know, this is just a typical example. All right. Then your differential. These are inductive. As the current goes there, you're going to have inductance. Comes around here, you're going to have inductance. So these X caps are going to work with that inductor to filter out all the noise between those two lines. These guys are common mode. So the current going this way and this way cancel. The noise it's meant to cancel out is the common mode. That stuff we pick up on the power cables that comes this way, or the stuff we generate that's going this way. So these things create a huge inductance in that case, because the current going this way creates inductance, current going this way creates inductance, big inductive field, okay? And they'll try to escape through these Y capacitors in the chassis. Same here. The power cable, if it has some inductance on it, it doesn't matter. The inductance here, here, and here swamp out the inductance of your cable. The capacitor here, capacitors here, swamp out the capacitance on that cable. That cable, as long as it has low enough ohms, low enough impedance to feed this circuit, that's all this circuit cares about. Once you get by here, you got clean power, and it's, well, actually coming in here, you're going to a switching power supply. The switching power supply's got to, it's got to, you know, you got to get through that, right? Let's talk about that. All right, guys. So here's our EMI filter. That should swamp out anything from the cable. Well, it will. But there it is. Look at all this other stuff. We got to go through a transformer, galvanic isolation, using a, you know, high pot meter, 1000 volts, let's say. Once, put one probe on this side anywhere, one probe on this side anywhere. Not going to read anything. There's no continuity. Galvanic isolation. Okay. So, power ground, secondary ground. You're going to go through this bridge rectifier. You know, you go through a transformer, right? Then you go through bridge rectifier. You have a big old bulk capacitor. You could have some LC. You could have some LC filters out here too, right? Big expensive, you know, amplifier. You think would have that. So you're gonna have some nice filtering out here. So then, let's say our voltage going through the rectifiers is going to look like this, coming off the transformer. The current going through the rectifiers is going to look like that. You have these big, huge pulses of current because that bulk capacitor is charged up. voltage up here on the sine wave has to get above the value of that bulk so that it can charge it again. And then it has this little small window at the peak there and the peak here, right? So you get these big old pulses of current. That stuff is a lot of energy. That little bit of energy that got that tuner to work on that receiver, it can't stand up to this stuff, okay? So a lot of stuff going on here. We're going to filter, we're going to have bulk capacitors out here, so a lot more stuff going on, right? Are you convinced yet that the power cable means nothing? Here, let's go a little further. Alright guys, so that EMI filter, it is going to swamp out any effects from your power cable. It just is. You know, one of the tests we do on a power supply is we'll test the conducted EMI. And that's just what's conducted on the wires from the power supply to the inlet power. And just make sure that we've cleaned up that noise so that we're not putting noise out to the power, okay? But the conducted noise, what we do is we measure that to see what we put on that power cable, okay? And I've done this test where it's on this long bench and you have these power cables, and what's funny is those little blocks that you see some speaker wire on, you'll see that on EMI chambers. And that's because the tabletop is ground, it's metal, and it's ground to the floor. And so it's just like an antenna system where you have a wire with some kind of emitting whatever. You put a ground plane beneath it, okay? And then you hold the wire above it. The speaker cables you see across somebody's floor in their house, it's not doing that. It's not the same thing at all. Even if it's on concrete, I don't think it's, I mean, you might argue that it might have some of that effect. I don't know if it would. I honestly haven't even ever tried that, but I don't know if anybody has. Again, there's not a lot of science to the speaker cables, but so on that bench you have this power cable running. I can't remember what it is. It's 1 meter or 2 meters, but I've taken a power supply, and once the EMI filter looks good, I've taken those power cables that are kept separate on these blocks and I put them over the top of each other. I tangled them up. Made no difference in the EMI signature. Okay, nothing. Alright, so hey, we've made it through the EMI filter, through the bulk capacitor, the rectifier, the bulk capacitor, and now we've got a switching power supply. So we got an LC filter to filter the square waves that we're generating here, okay? Now on this side it looks like AC again, so we've gone back from a bulk DC back to an AC. We go through these diodes and now we have an LC, another LC filter. So we get DC again over here. So how that power cord would have any influence on what happens here other than if it was just too small, it has none, zero. Okay? Many filters, galvanic isolation, many things going on. There's optocouplers, the feedback from this side to this side to maintain that isolation. So many layers of isolation and filtering going on. Alright guys, let's go a little deeper into the subject. Let's move over my beverage there. Alright guys, we got an EMI filter. Our power cord, did any of that stuff get through the EMI filter? Think maybe it did. Did it get through the power supply? Remember, now we got an isolated ground, secondary. So this stuff here, isolated from over here. Alright, then we go into our amplifier block. I just did a cutaway. So I showed a switch in place of the FETs or whatever you have out here, okay? And tied to plus V and minus V, okay? I show a graph here, and I'm just showing one of the rails as our signal comes out. We have plus V, and our signal comes out, and there's some margin. It doesn't get close to plus V, right? We keep it away from there, so we keep some margin. So this plus V can have some ripple. If we have an unregulated power supply, and our voltage is a little bit low on the input side, the cable might have dropped, you know, a few tenths of a volt or something, then this voltage, the plus V, might sag a little bit, might be a little bit lower, but we have margin built in. Any decent amplifier will. So there's margin built in. The better the amplifier, the more margin there's built in. Okay, so there we go. Now what? If any noise riding on top of this guy doesn't get there. So he keeps away from that stuff. So it could have some ripple from the power supply section. Anyway, we keep this thing away from there. So, alright, then we come out and then we have the Zobo network and inductor, capacitor and stuff like that, some filtering before we go out to our speaker. So, how a cable would have any impact on what happens out here past even into the EMI filter, unless it's a really poor cable with high ohms, I just think it's impossible. I think that's why we're supposed to join the belief system, because you can't measure, you can't prove it. So it's just, you know, you think about it, and if you're selling speakers, crossovers, amplifiers, whatever, and you're like, God, what else can we do? What else can we get out there? Accessories is where we make some money. That's the easy kill. It's like popcorn at the movie theater, right? It's like, okay, had to pay the stars, had to pay the production company to come up with this movie, but what else can we do when we got these people in here? Let's get them some popcorn, candy, and soda. Let's get them some power cables, some, you know, interconnects, and what else? Oh, let's get some little blocks to hold the cables off the ground. Come on, guys, think. What else can we sell them? You can imagine, right? So I have no dog in the race. You know, I'm not selling audio gear. You know, I'm gonna do audio reviews on how to design stuff and on modules that I bring in and kit building and stuff like that. But yeah, I don't have that. So what do you guys think? Alright guys, I just want to show you some cables that I bought, because I too worried about having good cables. And so back in the day when we had composite TV, I bought this bad boy, and it's auction free copper, it's shielded, and it's XOS brand. Gold terminals on it. It seemed well made, and it seems, you know, to have held up really well after all these years. So I know I didn't spend a lot of money on that. I spent a lot more than I probably needed to. But anyway, there you go. And then along came HDMI. And with HDMI, if it works, it works. You don't need to buy a cable. It's digital. It's looking for edges on those digital clock signals. So it's not looking for analog signals. It doesn't care about the noise or anything like that. It has great noise rejection. But I bought these guys, and they're twisted vanes. They're like 20-25 bucks. They're good looking. So if you want good looking cables, there you go. They have little gold, you know, contacts at the gold plated contacts at the end. So there you go. Kimber Cables TS series. Pretty cool. So this is a 4TC. This is 3 meters. This is about 318, 320 bucks, something like that. And yeah, it's braided cable. I think there's 13 different strands of wire that are all braided together. So pretty cool. There you go. A lot of money. 318 bucks is a lot of money. All right. And then I got the silver streaks. Okay, this is the 0.5 meter. This is 1 meter, and this has the WBT-0147 connectors on them. So they kind of twist lock. They're pretty cool. Connectors are really cool. I think they have a patent on those. This guy's like $3.99. The shorter one, a half meter. The full meter, I believe it's like $5.90. So very expensive stuff. You don't need this. 1 strand of silver, you got 2 strands of copper. So I believe the silver is on the positive and the 2 coppers are on the return. So if you guys know anything about circuitry, you know that current goes out and it has to come back. So if it comes back on copper, why couldn't it leave on copper? It's in series, right? So whatever goes out one way has to come back the other way. So if silver is somehow going to allow more current to go one way, it can't, because the two coppers have to bring it back. If the two coppers are good enough, why didn't you have two coppers go out? Save a lot of money. Anyway, sounds cool. That's why. Alright guys, I bought this cable for this video. This one is from W Audio. I know you never heard of it, right? Because it's less than 50 bucks. It's like $43 or something. Gold terminals on it. It's double shielded. Has a copper braid plus aluminum foil. Has 10 gauge wire. Oxygen free 99.99. If you like, I mean, it checks all these boxes that people look for. Gold plated terminals on the ends. They got these little plastic covers on them. Nice, you know, it's very nice stuff. And it's got this nylon sheath around it for, you know, to make it nice and strong. So there you go, 1 meter long, 10 gauge, under 50 bucks. So if you have to have this stuff, use my Amazon link. I appreciate it. I'm trying to save you money here, but you can go buy the lower cost cables. You don't need this, but if you just want a great cable that checks the boxes, there you go. You don't need to spend 400 bucks. You don't need to spend 250 bucks. And guess what? You can buy this. If you don't like it, Amazon will let you return it too. And this has a 5-year warranty. So there you go. Just saved you a bunch of bucks. It checks the box of the placebo effect, right? Beautiful cable. It's going to work beautifully. Alright, let's get back to the video. One more thing I just want to mention. The silver strands, silver conductivity is better than copper, right? We know that. But how much better? I believe it's like 7% better. Now, the oxygen-free copper, it's like 2%, I believe, better, 1 or 2% better than standard copper. So it's not a huge improvement. It's very little. It's great for marketing. It sounds great, right? The thing is, the silver is also more brittle than gold. Gold is more flexible. Copper is more flexible. So there's things to worry about with that too. Another thing to think about is wire gauge. Keep on talking about wire gauge. I believe it's every time you go up one gauge bigger in copper and wire gauge AWG, it's like 10% better conductivity. So it's better than going to silver. So there you go. Just go to a bigger copper wire. Oxygen free, whatever. Don't even worry about it. Let me know what you think about those comments. Alright guys, so yeah, just to wrap things up. The power cable with input has no effect. There's no scientific evidence. There's no engineering evidence. There's no measurable evidence. And the people that say, hey, I'm just going to help you guys up. I'm going to pull you up my collar and bring you up to my level of understanding. I mean, that is so pompous. That's demeaning to the rest of us. And you know, you want to call names. If anything, you guys are this guy comes from a flat earth camp where he's trying to get people to buy based on belief. That's sad. Yeah, that's sad, I think. So I don't know what you guys think, but let me know. I'm sure we're going to have a lot of comments on this. So I was going to say we got to get the industry straightened out, but really we just have to get the word out, and the word is out there already, I guess. It's just that there's people who are otherwise respected because of the other products they do, whether it's amplifiers or kit building or crossovers, that kind of thing. They have some knowledge in that, some experience in that, and they can prove it with science, with engineering, with data. But then they step into the murky waters of cables, and Kimber actually shows measurements. So that's good. It shows measurements of the actual cable. That's awesome. The thing with that though is I don't see the data showing, some vendor showing, hey, when I pair this cable with this amplifier, look what I get. If the sound stage is all of a sudden popping, is all of a sudden that much more noticeable, so obvious, then placing a microphone, the thing that actually captured the music in the first place, placing a microphone, not even a scope probe, not even a current probe. We're not even talking about those kind of electronic instruments. What we're talking about is placing a microphone in the room. So it picks up the stereo sound even, picks up the reflections, picks up all the things that you're hearing. Wouldn't you be able to show that on a graph with and without the power cord? And I'll bet you that you've tried. But in your head you're telling yourself why that didn't work, that there's something magical happening that we can't explain. And so you're going to pull us up by our knickers and feed us, your special lemonade, and we'll become believers. Now, if you're in that camp where you're like, hey, I got the bucks, I just want to cover all bases, and I want it to look cool, and I'm going to spend the money, then there is absolutely nothing wrong with that. So, lots of people buy Corvettes, really cool cars, because they're cool. I like four-wheel drives, I think they drive better. For me, they drive better than a car. They don't, right? But to me, I like them. So if you like your cables, then have at it. But to start calling names, calling people flat earthers and that, I think it makes you look silly, because it's just nuts for a flat earther to call an engineer a flat earther. It makes you look weak, Placebo effect is live and well. Nothing wrong with that. If you can live on the placebo effect, that's great. Nothing wrong with that. But don't mistake that with science. Don't mistake what feels good and what looks good with what sounds good. I mean, if it makes it sound better because you feel better about it, then great. But don't try to tell others that the actual sound stage is going to pop. Just say, you're going to enjoy your music so much better. It's going to sound so much better just because you love it so much better. There's truth in that. So just talk truth. Don't talk, pseudoscience. You can't prove. You can't measure. If you could, you would. You're making tons of money on this stuff. Making speakers or amplifiers, there's a process in that. The time the parts come in the door from the time they go out, there's a process. Building cables, a lot simpler process, a lot more bang for the buck, So when you say that there's not a lot of margin in that, that's total BS. And you know it, and we all know it. So anyway, okay guys, hope you liked the video. If you did, give it a thumbs up, hit the like button, because there's going to be plenty of the belief crowd, the people that come from the belief system, that that have this hatred towards the disbelievers, or have this dislike towards the disbelievers, and want to talk down to the science or the engineering community. There's plenty of those people that will give me a thumbs down. So anyway, just wanted to make some sense out of this, and we're here at KISS Audio trying to keep things simple and science and factual based for the most part. So alright guys, thanks for watching, and we will see you next time.